There we are. Alrighty, guys. Good morning. First things first, I guess. This is Zoom. So remember, if your camera is on, I can see not just you, but what's going on behind you. Please be mindful of that. I do record all of these lectures. I would love it if you guys would turn your cameras on so I can see your faces and get to know you a little bit today. But I just want to give you a heads up before that of course I am recording these lectures so they can be posted later on YouTube. And if you do turn your cam on, that will be a part of the recording that gets posted, just that little window off to the side. Alrighty. Today is day one of Calc 2, which is a wonderful class. I'm excited to go through all this stuff with you guys. We're going to do the normal day one stuff, like go over the syllabus, but we're also going to get started on some mathematics today. I will talk more about what the homework system is like and when homework is going to be due as we get into this. But you will have a homework associated with today's lecture. So even though it's day one, make sure you're ready to take notes and interact. I am going to go ahead and share my screen now so we can get started. That's going to come up maximized on your computer. I'll ask that you leave it that way so you can see what's going on over here. So first things first, this is what the blackboard for this class looks like. Obviously, we're doing this remotely. There's no physical blackboard. So I'll be using the document camera here to give you the notes. Anything and everything I write on the doc cam should go in your notes. That is a good general rule, with maybe the exception of what I'm going to put here right now. So this is MAC2312. Actually, go ahead and put this in. The section is 004. That's something that you're going to want to know. This is Calc 2. And today is the 23rd of August. The section number 004 is something that's a unique identifier for this class that you'll need at different times throughout the semester. So I suggest you remember that. Today we're going to do the normal first day stuff. So that includes going over the syllabus, which I'll try to make minimally painful. Talking about Canvas and WebAssign. A little bit class policies. Just kind of let you know how I run things. And then we're going to start on the mathematics. Specifically, in this class, we're going to begin in section 5.5, which is on u-sub and integrals. I'm supposed to assume that you guys are all masters of u-sub from Calc 1, but I've been teaching Calc 2 long enough to know that that's not necessarily the case, that we should spend a little bit of time on it. Technically, I'm supposed to assume that you're good all the way up through 6.1 areas between curves, but we're going to go through that stuff in this class just because I don't want to leave anybody behind. I know you've maybe had some time off since you did some of this, so practice is wise. Let's get into the first chunk of things here, which is the syllabus. So I will show you where to find that, and we can get moving. Alrighty, so in Canvas, you look over here at your courses, you should see somewhere here this Fall 21 MAC2312.004 Calc 2. That's us. Click that, it will bring you here. My name is John Filesticker. You can just call me Professor John or JP, whatever you're comfy with. I don't really care. I know that last name is a bit weird. Class meets Monday, Wednesday, and Friday, 9:30 to 10:45. The Friday meetings are technically a lab meeting, and sometimes we will do lab activities on Fridays, but for the most part, just think of it as a Monday, Wednesday, Friday class. We meet 3 days a week. Sometimes the Fridays will be a little bit different, a little bit more problem solving focused, but for the most part, it'll be just a regular class. Office hours, the ones I've set so far are Monday, Wednesday, and Friday from 1 to 2 p.m. They are in Zoom. You can click this link any Monday, Wednesday, or Friday between 1 and 2, and it'll bring you to a waiting room for a Zoom meeting. People like to discuss private things in office hours sometimes, like grade issues or personal things. So I don't want everybody just dumping in, but I promise I won't let you languish in the waiting room for long. If you're there for a little bit and I haven't said anything to you, feel free to send me a DM. But for the most part, I'll bring people in quickly. And if things are taking a while, I'll send you a little message letting you know what's going on and how long it will be. All right, first thing I'm actually going to ask you to do for this course. You ready? Get out your phones. Put this date in it. 12/8/21, December 8th at 8 a.m. That is when your final exam is. Put that shit in your calendar now with like 3 notifications. One that morning at like 6, one that morning at like 7, and one the night before at like 8 p.m. Make sure you get good sleep that night. Make sure you eat a nice dinner. Wake up early enough that you can drink your coffee, take a poop, do whatever, and then get to it, because the final exam schedules here at Santa Fe are fairly rigid. There's not a lot of room to move things around. As you're making your plans, I know a lot of people like to travel around the holidays. Don't forget, you have a final on the 8th, which is after classes end. Alrighty, other stuff I want to hit while we're on this page. If you haven't used the online tutoring here at Santa Fe before, I'm going to walk you through how to get into that. The tutors here are, for the most part, very good. They've been improving a lot over the last few years, and we can thank Larry in the Learning Commons for that. He's been putting a lot of time into training the tutors. If you click this link, which I'm going to open in a new tab. Oh, no. I used it this morning. Oh, no. All right. I'll fix the link now. Tutoring sources. Why did this break? It's the same damn link. Weird. All right. So if you follow this link, it will take you to the tutoring services page for the Learning Commons. You can scroll down here to math and statistics, and you'll see the times they have. So if you want to go actually physically to the library and get tutoring there, these are the days and times. If you want to get tutoring online, you see they've got some extended hours. They go later into the day on Monday, Tuesday, and Wednesday, which is nice. Monday, Tuesday, Wednesday, and Thursday. The way to get to the actual online tutoring from here is to follow this link. Click Math, Sciences, and Business, and that will take you here. If you want to talk to somebody about a homework problem or just a concept from class or an example problem that's giving you a hard time, you're stressed out about it, it's bugging you, just go to those, follow that sequence of links, and then click right here. And this will dump you into a waiting room where you get matched up with a tutor. You'll tell them what kind of math you're working on. They'll find a tutor who can help you with it, and they're pretty good. I can specifically recommend Alejandro. Alejandro is a badass. He will help you with any of the stuff, including power series representations, the tricky stuff at the end. He's very, very good. If you have a good time with a tutor, especially good time, let me know. If you have a bad time with a tutor, especially bad time, let me know. Those are things that we want to constantly be working to improve. Other stuff here is pretty basic. I don't care how you pronounce my name. I don't care if you don't want to pronounce it. If you want to try, this is how you say it, file sticker. I am on your team. We'll talk a little bit more about this later, but anytime you're stressed, struggling, whatever, just let me know, reach out. I will work with you, I promise. There's lots and lots of ways I can help you. Extra office hours, I can help you find better tutoring. If you need that, I can help you with dates, moving things around. I promise you I'm on your side, but please talk to me. The more you communicate, the more I can help. If we don't communicate and then at the end you're like, I'm fucked, I'm in a much harder position to help you. So please talk to me throughout the semester. Let me know if you're having a hard time, and I'll do everything I can to smooth things out. This last bit down here, we're going to do some hard stuff in this class, right? Calc 2 has a bit of a reputation for being the hard calculus class. I love teaching it. One of the reasons is because it's a hard class, but also because the concepts we're going to play with are really beautiful and really deep. That means it's going to take a lot of time and effort on your behalf, though. So you need to be working on this stuff every single day. I'm going to publish a homework assignment for you guys today. It will be due next Monday. We'll talk about the homework schedule in a little bit. But you need to be working on it every single day. As long as you do that, as long as you put in a little bit of time every single day, you keep it fresh in your brain all the time, then you'll find this class easier than you thought. But if you try to get it all done like once a week or something like that, you come in on Sunday and go like, all right, I'm going to watch all the lecture videos on YouTube because I didn't go to class over the week, and then I'm going to do the homework and everything's going to be good. It's not going to be good. I promise you, it does not work. Really does not work for this class. Coming over to the modules. I have here a medium-sized collection of stuff that you should know, stuff that you should know well, things like how to divide polynomials, things like the definition of the inverse tangent function, how to evaluate the inverse tangent of -1, or what does it mean to say arc sine of √3/2, all that stuff, kind of basic things that you should know, including Calc 1 integration rules, some basic integration problems, things that you need to have rock solid from your Calc 1 days coming in. Pay special attention to the trig. Right, this is one thing that I notice catches people out in Calc 2 a lot. A lot of Calc 1 classes don't have enough trig in them. We are going to use trig all the fucking time in this class, constantly working with trigonometric functions. So I recommend everybody take a look at least these guys. Let me even do one further here. I'll jump into this one. So this is a link to Paul's online notes. You'll see me link to this a lot throughout the semester. It's a great resource. It has definitions, examples, practice problems with step-by-step solutions that you can reveal. Any topic here that does not immediately go, yes, I know exactly what that is and I know exactly how to do it, spend some time on it. Spend some time on it this week. The ones that I see people getting into trouble with a lot are these trig formulas, and these inverse trig functions. So you got to know what inverse trig functions are. Has nothing to do with the reciprocal. Of course, the alternate notation is like arc this, arc that. And you see here just basic practice stuff, right? Like what is the inverse cosine of √3/2? Or what is the inverse tangent of 1? How do we simplify shit like this? All of those things will matter a lot as the semester progresses, and you may want to bone up on some of it. In addition to that, make sure you know your trig identities, like sine 2t is 2 sine t cos t. And if you want to expand some more complicated expressions or collapse complicated expressions, you'll need to use those identities. So the Pythagorean identities, sine squared plus cos squared equals 1, of course. Tan squared plus 1 equals, what is this guy? Oh, hold space bar to talk, by the way, sorry.
I want to say secant squared.
Very good, secant squared. So tan squared theta plus 1 equals secant squared. These top two, we'll refer to these as Pythagorean identities. This one, sine 2t is 2 sine t cos t. That's a double angle identity for sine. Spend some time in here, right? Make sure you know your basic trig identities and make sure you're comfortable with the definition of inverse trig functions. And then anything else in here that doesn't immediately go, yes, I know exactly what that is and exactly how to do it, look at it. Spend some time. Solve at least one problem. I've got modules up for the first few sections that we're going to cover after that. Some of the later things here are not as fleshed out, but I'm doing my best to try and get you lots of videos and things to look at. There's no assignments here in the modules. It's just stuff to help you. If you're struggling with some content, come to the modules, go down to that section, and you can watch some videos or go to Paul's online notes and work some example problems, that sort of thing. The assignments I haven't posted yet. I can show you what those are gonna look like. I'll just show you my differential equations class from the summer. So I will populate the Canvas page with assignments, but there's not anything for you to go in there and do right now. It's just that the gradebook works. And so there's gonna be a spot for homework. There's gonna be a spot for study guides. There'll be a spot for each exam. And that's pretty much it. And that way, once those are in, you can go into the grade book and enter those little what if scores and calculate your grade. So anytime in the semester, you should know what your grade is in the class. Okay, obviously, you know when the class meets, you know how to get here. So grateful that you're all here. Office hours again, Monday, Wednesday, Friday, 1 to 2 p.m. Click this link. It'll take you to the Zoom meeting. Final exam, everybody put this in their phone, right? 12/8/21 at 8 a.m. Make sure that's in there. The other things I need you to do, go ahead and click here where it says click here to access the full course syllabus and save that, right? Save it somewhere on your computer where you can find it. So it'll bring up a prompt to download, save file. I have a spot here where I put all my stuff for you guys. All 21, Calc 2, it's already there. I'll save another copy, why not? And then we're going to talk through this. Let me open it in my native thing here. All righty. So this is the syllabus for our class. Everybody needs to save a copy of this somewhere they can get back to it because you'll refer to it often. There are a lot of kind of basic questions where I'll be like, hey, it's in the syllabus, go check that out. I'll try not to do that because I know it's a little bit dismissive, but I want you to read this and understand it. That way we don't have any of that going on. We already went over when the class meets and when the office hours are and when the final exam is. I think that's a Wednesday. Gotta fix that. December 8th is a Wednesday. Good. Yeah. Okay. My physical office on campus is A031D. That's downstairs on the north side of building A. I'm obviously not there very often. You see, I'm here at home. There's a crazy puppy in the crate behind me. There's a baby over there. You may hear things like that from time to time. I'll try to not be disturbing. This phone number rings in my office, so obviously I'm not there a whole lot. I do have it set up to forward to my home phone, but I don't get caller ID or voicemail. So if you try to call me on this number and it goes to voicemail, don't bother leaving a message. I can't retrieve them, or I retrieve them like once a month when I go there physically, and it'll be too late. By far, the best way to get a hold of me is Canvas or this email address. So Canvas messages are actually the best because it tells me what class you're coming from, gives me all the information that I want at the start. But if you want to email me directly, that's fine. I get it. This is the email to do that. Just make sure you include this information in the email. So you're in Calc 2 and you're in Section 4. Prereqs for the class, obviously you had to succeed in Calc 1. The text for the class is the same as the text for Calc 1. It's the 8th edition of Stewart's Calculus, the early Transcendentals version. I can show you what that looks like. Here's what that looks like. This is my old beat up copy of Stewart. Make sure that you have the early Transcendentals version, not the late Transcendentals version, if you're going to buy a copy. But you don't need to buy a copy. The only thing you do need to buy for this class is the WebAssign access code. And you need to get that stat. I need every single person in this class to register for our class in WebAssign today. Even if you don't have your access code yet. You're just going to go here in Canvas, follow this link to WebAssign, and enter class key. The thing you're going to put in for the class key is this. It will eventually ask you for an access code. If you don't have your access code yet, either you're waiting for financial aid or you ordered it online and it hasn't come yet, whatever. If you're still waiting for your access code, scroll down on that page. You'll see a little link somewhere on there. It's usually grayed out a bit. It says, continue with free trial or continue with temporary access. Click that. That will get you in for the first 2 weeks. After those 2 weeks, it'll kick you out unless you've put in your access code. So make sure you do have an access code coming. But if it's not here, you can still register. All you need is this class key from the syllabus. And then use the trial access, the temporary access, if you don't have your access code yet. Calculators, you do not need a calculator for this class. I want to be clear about that right at the outset. In fact, I would recommend not using a calculator. But I know some people like to use a calculator to check their arithmetic. I get that. I'm a little insecure about my own arithmetic. If you want a calculator for arithmetic purposes, the TI-30 is acceptable. TI-30 II or TI-32XS. That's the only one you're allowed to use. No TI-30 Pro, no TI-36, definitely no TI-84, 89 Inspire, none of that stuff. Has to be one of these basic guys. You can pick one up at Walmart for around 10 bucks. It's the same calculator that's allowed in all the calc classes here at Santa Fe and differential equations. So if you're a calculator person, you like to have one handy, that's the one to get. No other calculators can be used on exams. You're welcome to use other calculators or Desmos, things like that, as you work through the homework. In fact, I encourage it. You'll see me use Desmos here a lot in class. It's a great way to look at things and get examples. But make sure you're capable of doing the homework by hand. Right? Because that's how you're going to be tested, is by hand. Specifically graphing, right? You need to make sure you know the graphs of sine, cosine, the natural log, all the basic exponentials, trig functions, polynomials, blah, blah, blah. Other thing you're going to need, obviously, is a working computer. Keep your web browser up to date, right? Anytime Firefox or Chrome or whatever asks to update, let it update, or at least update it within 24 hours because certain things can fail if you don't, like honor lock. You need consistent internet access, and this is a struggle thing for a lot of folks, including me. Last spring, Cox Cable just really fucking dropped the ball at my house. I was getting kicked out of class meetings all the time. It's a pain in the ass. I get that it's a pain in the ass. I use my phone's hotspot as a backup in case stuff like that happens. Make sure you have a backup. If your internet is not super duper reliable, make sure you have a place you can go where it is super duper reliable, or you have a reasonably quick hotspot on your phone, especially for exams, because when it comes to exams, I'll need you to have your webcam on. And I'm also going to require you to sign into Zoom on your phone for the tests. So you'll be using HonorLock on your computer, and you'll be using Zoom on your phone. And I am very, very picky about the way things are set up. I'll warn you ahead of time before that first test. I'm going to bug all of you and be like, no, the phone camera needs to be looking exactly here. And I need to see your desk, your hands, your lap, all that shit. We're going to talk about cheating later. But if you want to avoid all of that stuff with the exams, all of my pain in the ass proctoring rules, you're also more than welcome to take the tests in the testing center on campus. So that is another thing that we can do. But just for the lectures, right? You're required to attend the lectures. I want you to be able to ask questions and have this back and forth with me. You need to be able to see the notes, which means you need a computer and sufficient internet access to get this thing streamed legibly. Got to be able to see what I'm writing. Moving on, this is Calc 2. It's the second Calc class. The main purpose here is to get you really good at integration. So finding antiderivatives and evaluating definite integrals. We're going to do those a bunch of different ways. We're going to talk a little bit about applications of the integral. So some things that you can calculate from physics and statistics using calculus that you can't find other ways. That's the first big part of the class. The second big part of the class is sequences and series, specifically power series, getting you to a place where you can write pretty much any function as a big, long polynomial. Turns out to be probably the most important technique, mathematical technique in engineering and pretty much everything, honestly. Power series are the shit. The last chunk of the class is going to be some kind of disparate application problems, things that will be useful in Calc 3, like parametric curves and polar coordinates, the whole concept of a coordinate change. And we'll see how to do calculus kind of in a few different settings than what you're maybe used to. But that's basically the breakdown of the course. 3 big pieces: integration, series, and then applications. And we'll be going through them in that order. Cell phone policy, this is not as important because this is not an in-person class, but please just don't distract other people. I guess the Zoom version of this is keep the chat here calm, focused, and civil. If you want to post things in the chat, in the lecture chat here in Zoom, you're welcome to do that, especially if you want to ask questions of me or you want to see something else again or anything like that. The chat is a good way to do that, but let's keep it focused on class. At the same time, you may have noticed I posted a link to a Discord server for this class. It's in the announcements. It's just in case I lost it. Yeah, a bunch of folks are already here. The Discord should be relatively quiet during class also. So, if you've got something you need to ask it here. Let's not distract other people. Well, there's stuff going on. Attendance. I will take attendance every day using the Zoom logs. So please sign into Zoom using your name as it shows up on your SFID, right? I need to input attendance into eStaff for you to get your financial aid. And the way I check attendance is using the Zoom logs. So I know sometimes if you sign on your phone or whatever, it'll just say like, John's iPhone or something like that. It really doesn't help me. So I need first name, last name here in Zoom as it appears on your Santa Fe ID card. There is no attendance component to the grade, but I do use attendance to help me figure things out. Like at the end of the semester, if someone's like, oh, I didn't do these homeworks, and is there any way you can let me work on these homeworks after the final or something like that? I may look and see, oh, well, have you been coming to class? Like, do you give a shit? Like those sort of special asks of me, I will often look to attendance to see whether they are appropriate or not, if you've been putting in an effort to show up. But there's no attendance component to the grade. You're not mandated to attend by any grade things, but I strongly recommend it because showing up to class, asking questions, taking notes is the #1 predictor of success. Makeups. I'm pretty lax about this shit. If you don't get a homework set completed to your satisfaction by the day it is due, that's not the end of the world. Just submit an extension request in WebAssign. I pretty much always grant them. But I'll warn you, if you fall behind on the homework, you're screwed, right? This class moves incredibly fast. We cover a lot of really difficult material and it all builds on the previous thing. So I'm gonna have homework due once or twice a week. I think right now I've got just in the syllabus, I say there's one homework set a week on WebAssign. There will be some weeks where we have two, like I'll have one due on Monday, one due on Wednesday, something like that. But the way it works is that the homework will be due at the start of class every Monday. Certainly every Monday at the start of class, you will have a homework due. And some weeks I'll have an extra one due on Wednesday at the start of class. The idea is, in order to understand that Monday's lecture or that week's lecture, you need to have finished the homework that was due at the start of class that Monday. 3 midterms, right? Three exams in the class, and before each midterm, I will assign a study guide. Those study guides are going to be select problems that I think are extra important for whatever reason. They get at the core concept, or they kind of require you to do all the special things for a certain type of problem. Those study guides are a special grade component. You'll find them in WebAssign about a week before each midterm. I'll post them. The way you get the grade for the study guide is not by completing it in WebAssign. The way you get the grade for the study guide is by submitting on Canvas the written work that you have for those study guide problems. I want you to submit those as soon as you can. So I'll post the study guide about a week before the test. I want you to solve those problems and write out your solutions. Then you're going to scan those solutions and submit them to Canvas. That way, I can get in there and give you some feedback. I can be like, oh, on the test, this would be a ½ point off, or oh, on the test, this would be perfect. That way, you know exactly what to expect from my grading. You know exactly what I want from you as far as work quality, legibility, all of that stuff. So you want to solve those problems as soon as you can and submit them before the test, right? The day the study guide is due, the absolute last day you can submit those is the day of the test. Because I don't want to penalize you if you happen to procrastinate a little bit. But in order to get the most out of them, you need to be working on those problems that whole week before the test, talking about them with your classmates. Discord is a great place for that. Talking about them with me in office hours, a good place for that. And then submit the work as soon as you can. That way I can get in there and mark it and give you some feedback, and you'll be nice and ready for the test. No surprises. Again, to get credit for the study guides, you have to turn in the written work no later than the day of the test. All right, lab meetings. So like we said, each Friday is technically a lab meeting. Usually these would be problem-solving sessions where you guys either solve problems yourselves or request problems to be solved. We talk through solutions to problems. And in the back in the long ago, before COVID, I used to give extra credit points where students would come up to the board and present a solution. I may try to figure out how to do something like that here. I haven't found a nice way to do that online yet, but perhaps extra credit points for telling me what the next step is, something like that. But most Fridays will just be regular class days. We will occasionally do special projects that use things like Desmos or Maple. Some days we'll do these problem-solving sessions, but for now, just think of Friday as a regular class day. Back to exams again, 3 midterms, 1 final. 4 tests altogether, 3 midterms, 1 final. The final is cumulative, covers everything. The midterms just cover what we've talked about in class between the prior midterm and that one. So the first midterm is on integration techniques, second midterm is on sequences and series, and the third midterm is on applications. The final covers everything. Right now, I'm proctoring everything with HonorLock and Zoom. I'm open to other ideas, but I'm trying really hard to squash cheating. I'll talk about cheating a little bit more in the future. Remember, the final is on the 8th. If you haven't put this in your phone yet, please go ahead and do that. Recording notice, I mentioned this at the start of class, but I do record these meetings so I can post them on YouTube later. If your cam is on, then you will be included in a little window down here. I understand if you don't want that, but on the other hand, it's nice for me to see your face, see how you're reacting. It'll really help me with pacing the class. So if you're willing to leave your camera on, I much appreciate that. Just be aware that you will be included in that recording. I promise nobody watches my YouTube channel except my students. Some dates that you may want to keep in mind. Today is the first day of class. The last day to add is the 25th. The last day to bail and get your money back is the 27th. All right, this is definitely one to keep in mind. So if you decide you just really don't like the format of the class, or you really don't like my teaching style, or you're just not into this right now, the last day to get your money back, get out, and not have anything show up on your transcript is the 27th. Closed for Labor Day on the 6th of next month. Closed for whatever reason, because UF's homecoming on the 1st of October. The last day to get a W, the last day to withdraw from the class, you don't get your money back, but you don't get a letter grade, you just get a W, which is certainly better than an F, is the 2nd of November. So if you hang in here beyond the 2nd of November, you're going to get an A through F letter grade for the class. But if you decide around this time, like, oh, there's no way for me to pass this class, or I just don't have time to study for the final, whatever it is, this is your last day to jump ship. A little note here: to withdraw beyond this day, you have to use a petition. Closed for Veterans Day on the 11th, closed the 25th and 26th for Thanksgiving. Last day of class for us is the 2nd of December. Final exams again 12/8, and then the grades will be posted to East Santa Fe no later than the 14th of December. Take your time, look at these. Any of them that you think are relevant, be sure to add to your calendar, just like the final. Again, make sure this is please, please, please in your calendar. I do not want anybody to miss the final exam. That is really hurting. The ones I would definitely put in your calendar are the last day for the W. You want to stop and reevaluate how you're doing in the class on this day. And the last day to drop with refund. Those are the ones that I would make sure are in your phone. All right, the grade breakdown for this class. It's mostly tests. We've got 3 midterms, each one's worth 100 points. That's a little more than half the grade. We've got a final that's worth 150 points. That is a little bit more than a quarter of the grade. So you see between these two, you have more than 75% of the grade. More than 75% of the grade comes from proctored exams. Remaining stuff comes from the study guides. So there's going to be 3 study guides. Each one is 25 points. They come to a total of 13% of the grade. And I'll say again, remember to get the credit for the study guides. It's not about solving the problems in WeatherSign. It's about submitting the work to Canvas. It's the written work for the study guides that actually get you this 13%. That's a big chunk. And then the homework is the smallest component. It's only about 8% or 45 points altogether. The grading scale that we use is the standard one. 90 to 100 is an A, 80 to 89 is a B, and 70 to 79 is a C. And with the top 3 points in each category, you get the plus designation. I'll tell you, people always ask me at the end of the semester, do you round up? If you're within a point of the next letter grade, then I'll round you up. So like 79.1 is definitely a B. If you're like a 1.5 out, then maybe. If you're more than a 1.5 out, I don't round. So like for example, what did I had a 67.9 over the summer in one of my pre-calc classes, and she really wanted the C, of course, to move on, and I felt quite bad, but I couldn't round that up, right? So within a 1.5, you're good, but more than a 1.5, nice. There is no extra credit. There is one kind of forgiveness component here. The study guides, first, are a big forgiveness component. These are not graded for correctness. Don't cheat on the study guides. It doesn't help. The study guides are just graded for completeness, right? Completion. As long as you have a good faith effort on each problem, you're going to get the full 25 points for each study guide. That's a free 13% in the class. Don't miss those. The homework, knock it out. I know that everybody's capable of getting those homeworks completed. I'm happy to grant extensions if you need them. That's a free 8%. And then the other thing is that the final will replace your lowest midterm. So if you have one midterm that just goes really badly, as long as you do decently on the final, you'll be okay, because the final will come in and take the place of that lowest midterm. But that's it. There are no other extra credit or bonuses or anything like that. The next page here is all pretty standard boilerplate stuff. GELOs, General Education Learning Outcomes. These are a few stats, a few particular kinds of problems that I track your responses on throughout the semester to see how I'm doing as a teacher, and I publish those for the state, but it has no bearing on your grade, doesn't show up in your transcript. Academic integrity, this is something we're going to talk about a little bit more in a second, but it's really important that you guys don't cheat. I'll tell you some stories. I have failed shitloads of students in the last year and a half for cheating. I'll tell you some bad stories, some good stories. But I strongly recommend that you guys read this. Follow this link right here. It's a long document, and I don't necessarily suggest you read every little bit, like the philosophy and overview. Oh, okay, that's great. Definitions, everybody knows what college means. Everybody knows what instructor means. But make sure you read the portions that are particularly relevant for our class, like what is prohibiting conduct. You want to know what that is, right? You want to know what you're not allowed to do, the sort of stuff that will get you in trouble. So take the time, leaf through that, make sure you understand the basics. Americans with Disabilities Act, the ADA, is a great piece of legislation. that guarantees if you have a disability of any sort, learning disability or other disability, that we have to accommodate you, which is a really good thing. So if you are registered with the DRC, or you think you may be entitled to any sort of accommodations, regardless of whether you're registered with the DRC or not, just reach out to me at the beginning of the semester, like now, and we'll make sure you have everything you need. If that's having a note taker to watch the lectures and provide nice notes for you, we can do that. If that's having a testing environment that is less chaotic and annoying than like Zoom on your phone and Honor on your computer, we can do that. Whatever it is you need will help. And if you're registered with the DRC, that's great because they're super duper helpful. If you're not yet registered with the DRC, that's okay too. I'll still work with you, right? So even if we have to do the accommodations on our own outside the DRC, just talk to me, we'll make it happen. Accessibility, everything I publish for this class is typed in the LaTeX markup language, published as a PDF. It works great with screen readers, even the mathematics. If you have any trouble accessing or reading, understanding, hearing, viewing, whatever, any of the class materials, because there are YouTube videos, there are PDFs like these, there's stuff on Canvas. I do my best to make it all ADA compliant. But if you need trouble, or if you're having trouble with a screen reader, or you need help with anything else like that, just let me know and I can help you out. Discrimination, harassment, this is pretty obvious. Just don't be an asshole, right? Be nice. Be nice to me, be nice to your classmates, be nice to any staff at Santa Fe. They're all working really hard, and we all do this because we love teaching. We love helping people learn. Life, and especially college, can be stressful and frustrating, but try to be mindful as you talk with everybody on campus or anybody related to school. Just be kind. Student rights and responsibilities, kind of like the thing above. I recommend taking a look at this and knowing what you're expected to do and what you're expected to not do. In particular, here comes the good stuff, right? Extra notes on cheating. So I know right now, over the last year and a half, with everything being online, that the temptation to cheat is larger than it has ever been before. I also know that not every teacher out there is very good at catching cheating, right? Some people don't even try. I'm not that guy. I'll tell you right now, I'm not that guy. Story's coming. I do review the Honor videos. I look very carefully at your written work. It's one of the reasons I require you to submit written work for the tests. I also require that you type your final answer within the test during the proctoring, and that final answer has to match the answer on your written work, which you submit after the test is complete. If I feel like something is shady, I will not hesitate to start a conduct trial. So over the summer, in one class on one test, the largest number I had was six students, and 5 of them admitted to cheating right away when I presented the evidence. One of them is fighting it a little bit. My record is 9. So last fall, I had 9 students fail the Calc 2 final because they cheated. And it was really obvious the sense in which they cheated, and they all fried. Not a single one of them tried to fight that shit. I'm good at catching cheating, right? I'm aware of Photomath, Symbolab, Mathway, Wolfram, all that shit. I have the apps on my phone. I run my own shit through those apps, so I know what to look for when I come in and look at your work. And if I see something that kind of looks suspicious to me but doesn't match any of the obvious cheating software, I send it off to a couple other people who I know are very good at catching this stuff. Don't cheat. Don't fucking cheat. Please don't fucking cheat. I'll catch you. All right, I will. And then I'm going to feel bad. You're going to feel bad. We're going to create work for the student affairs office. It's just not fun for anybody. I promise you, I'm better at catching cheating than your last math teacher. Please don't cheat. If you feel tempted, and I understand that this happens, right? I get it. The test is 3 days away or 5 days away or 2 hours away. And you're like, oh my God, I'm so fucked. And your brain starts flipping into that mode where you're like, okay, what apps can I use? Or okay, where can I take this sheet? I get it. Don't feel bad. But instead of doing that, reach out to me. Okay. I'm stressed. I'm not ready. I can't handle this. Let me know. Just let me know. All right. If it's early enough, then I can get you some extra one-on-one office hours. If it's close to the test and there isn't enough time to get you ready, then I'll extend the due date for you. I'll give you a little bit of extra time. You can take a makeup test. I always have at least 1 or 2 people who are sick or something happens, so I always have to do makeup tests anyway. I usually plan them for about 1 week after the original test, and that'll give you some extra time to prepare. But don't cheat. All right? If you cheat, I will catch you. But if you talk to me, I will work with you, and that will work out way, way, way better, I promise. So don't cheat. Just reach out to me if you're starting to feel that kind of stress where you're thinking, you may end up doing something that is in any way cheaty. Even if you're not trying to figure out where to hide your phone, talking to somebody else about a take-home test, or sharing material with somebody else, or having somebody, on the opposite side of the computer that can look at shit and give you a nod or a wink or whatever, anything like that. I promise you I'm better at catching it than you think. I really don't like getting people in trouble for it, but I have to do it all the time because somebody always thinks they can sneak it by. I'm trying to give you a release valve here, right? I'm trying to give you an opportunity to not do that and still get a good grade, because I don't want you to cheat. I really don't. I do want you to learn the material, and I'll work with you to make sure you have enough time and all the resources and everything to learn it. Just reach out to me instead of cheating. I told the two bad stories, right? 6 on one test over the summer, 9 on one test last fall. I also had 2 students in differential equations this last summer who would not have passed the class if they took the test on the test day. And they reached out to me and said, I'm boned. I don't understand the Laplace transform. I'm having a really hard time remembering improper integrals from Calc 2. Is there anything we can do? And I gave them an extra week to prepare. We spent a little bit of extra time in one-on-one office hours. One of them got a low C and the other one got a B in the class. So I promise you, this works out way, way, way better than cheating does. All right, that's my spiel on that shit. Here's the course calendar. This is a rough outline. There are some things that will mess with this inevitably, like holidays and hurricanes and football games and people traveling. But this is about when we're going to do what. So the first week, this week, we're going to talk about some integration stuff you're supposed to have learned in Calc 1, like 5.5, which is substitution, 6.1, which is areas between curves. And then we'll also talk about section 6.5, which is this thing called average value. In the second week, we're going to talk about volumes. So there are some solids whose volumes you can calculate using not too crazy methods, but they have to have a lot of symmetry. So they're usually volumes of solids that come from rotating a 2D region, something like that. We're going to talk about those things in the second week. We're also going to talk a little bit about this physics concept called work. And then from there, we're going to dive into chapter 7. Everything from there to here is how to do integrals, right? Hard integrals, integrals that you can't do with Calc 1 tricks. And then we'll be ready for the test. After the first test, we're going to move into the second part of the course, which is all on convergence. So convergence is kind of a loose word. It's a word that can mean many different things. But in brief, it's when you have an infinite process that leads to a finite result. So those may be integrals, definite integrals, that instead of going from 0 to 5, you go from 0 to infinity. We'll also have a notion of convergence for an infinite sequence, a list of numbers, whatever it might mean for a list to converge. And we'll have notions of convergence for series and power series. And that's that middle chunk of the class, sequences and series. Once we finish that, we'll be ready for exam 2. This is going to be around the 10th week. So if we are able to keep to this schedule, that will be before your withdrawal date, right? Your withdrawal date was 11/2 or 11/11, I think I had 11/2. So hopefully we'll get exam 2 done and graded before you need to decide whether to stay in the class or not. And then the last third of the class, we're going to talk about more series, this time power series, and then some application problems relating to parametric curves and polar coordinates, and then we'll be done. All right. So that's the syllabus and my sort of rant about cheating. Do you guys have any questions for me? Anything you'd like to ask or talk about?
Our exam's gonna be on Mondays or Wednesdays?
That depends a little bit on when we finish the content. So I like to give you guys a full week to work on the study guide, and I like to publish the study guide after lecturing the last bit of material that's on the exam. So it depends on kind of where we are, what day of the week we finish the lecture for that test. So if the last lecture for exam 1's material is on a Monday, then we'll have that exam the following Monday. If the last lecture for exam 1's material happens to be a Wednesday, then we'll have that exam on a Wednesday, and so on.
Thank you.
Yeah, of course. Any other questions?
Are we going to be ever meeting in person? Because I know this is technically a hybrid class.
Yeah, good question. So we don't have any required in-person meetings. The big difference between a hybrid class and a fully online class is that a hybrid class has a set meeting time. So, excuse me. The fact that we're meeting every Monday, Wednesday, and Friday at 9:30 is kind of the hybrid designation here. So we have a set meeting time and we have a set time for our exams. Fully online classes don't have any set meeting time. You just watch videos online and then you take the tests within any like 3-day window at the testing center. So the hybrid thing isn't a necessity to meet in person, it's a necessity to meet at a particular time. And that's because I find that the kind of rigor of a schedule really helps people stay in flow with the course. It's easy to fall behind in an online class because nobody's checking up on you every week. So no in-person meetings are required. However, if you want to meet in person, we can. That's this or by appointment thing. So you can schedule an office hour with me in Zoom. If you want an extra office hour outside of the Monday, Wednesday, Friday 1 to 2 thing, you can say, hey, can we meet on Saturday at 3 p.m.? And I'll say, yeah, do you want to meet in person or do you want to meet online? If you want to meet in person, I'll ask that we mask up. It's not a requirement on Santa Fe campus right now, but because I have an infant at home, I'm trying to be very careful. So I will ask that you wear a mask, but we can meet in person if you would like. However, it's not required.
Okay, thank you.
All righty. Anything else from the syllabus or kind of class structure, policies, anything like that? Could I see using the Zoom Reacts? Anybody just give me a thumbs up or whatever if you've never used WebAssign before. First class with WebAssign. Okay, we got at least one. Okay, so I would recommend that everybody get into WebAssign today. I know I said this earlier, but I just want to, before we move on, finish with this for emphasis. Everybody should get into WebAssign today. You can follow this link in Canvas. It's on the home page in Canvas. It'll take you to WebAssign. And even if you don't have your access code, you can still get in. There is going to be a homework going up today. That homework is going to be due next Monday at the start of class. And I may publish a second homework on Wednesday. Really got to stay on top of that stuff. I know there are ways to get the answers to put in the box and get the grade and move on. That's not the point. The grade for the homework is worth very, very little, only 8% altogether. The point is to get you practice. You really need to practice these things in order to understand the next bit of material. So even if you don't have your access code, even if you don't know when it's coming in, go ahead and sign up for WebAssign. All you need to do that is the class key from the syllabus here.
Do you know how many tries we have on the homework?
Yes, so I've set it to 55, which is the max. You have as many tries as you want, and I'm doing that to discourage using things like photomath or whatever, because I would much rather you get it wrong 5 times and then get it right. I know how much it sucks when you're like, fucking last attempt, oh, let me just go over to photomath and make sure it's right. Fuck that shit, don't do it. Work it until you get it. Work it until you get it. I'll help you if you're stuck. Send me an email, send me a picture of your work, go on Discord, ask one of your classmates, something like that. Work it till you get it. You're not going to run out of tries. If magically you go to 54 tries and you're on 55 and you're not sure, let me know. I'll find some way to fix it for you. All right. But yeah, 55 tries on each problem within the homework. You don't ever have to stress about that. Any other questions? All right, we all have the final exam in our phones. It's on our calendar there. It's going to ring. It's going to let us know at least a couple times, once early that morning, at least once the night before. And we're all clear where the grades are coming from, right? Okay, then. It's time to start doing some mathematics. We're going to start section 5.5, which is u-substitution in integrals. So one thing that you may want to do if you haven't done it recently is crack open your textbook to section 5.4, where you have this list of indefinite integrals that you should know. So these are all the basic rules, like constant multiples pop out and you can split up over addition or subtraction. And then everything from here down is stuff that you really need to know. Just basic antiderivatives. These are your basic derivatives from Calc 1, just rewritten backwards in terms of integrals. So like, you know, the derivative of the natural log of x is 1 over x. So the integral of 1 over x is the natural log of x. And it turns out to work great, even if x is negative. That's why we have the absolute value here. All of these are things that you should know. Ones that people forget, this one, like how do you integrate 2 to the x? People forget this shit all the time. And then these ones down here at the bottom, the inverse trig functions, people tend to forget those a little bit. So make sure you know all of this, because I'm going to be beginning here in 5.5, which is on substitution. So let's do it. I'm just going to call it u-sub because that's what everybody calls it. So we know how to do, for example, the integral of the square root of x dx. I'm looking for the most general antiderivative of the square root of x. So who has the square root of x as his derivative? We do this using the power rule. I can write the square root of x as x to the 1/2. So make sure you're using good notation. Always write your integrals, always write your dx's. These things matter. And then following from that power rule that you saw on your table there, the way you integrate a pure power of x, x to some number, is by adding 1 to that number and then dividing by that new number. And because it's an indefinite integral, there are no bounds here. We slap on a plus c because any constant would differentiate to 0. So this, whatever this function turns out to be, that thing plus 5 would have the same derivative. 1/2 plus 1 is 3/2. So this is x to the 3/2 divided by 3/2 plus c. And then dividing by 3/2 is the same as multiplying by 2/3. So this is 2/3 x to the 3/2 plus c. So hopefully everybody remembers how to do this. But how could we do the integral of the square root of x plus 1 dx? Well, the big idea here, first a comment. The square root of x plus 1 is very much not the square root of x plus the square root of 1, which would be root x plus 1 like this. All right, this shit don't work. This shit never works. Square roots and powers in general do not distribute over addition or subtraction. I can't tell you how often I see this. Please don't do it. If this did work, then okay, we just integrate this and this separately. But since this doesn't work, we need to do something else. So we can't say integral square x plus 1 dx equals integral square root x plus 1 dx. This never ever works. Neither does anything that looks like it. So please don't try to do that stuff. The big idea here is that if the inside was just one variable, if it was just the square root of your variable, then you know how to integrate that. That's what we did up here using the power rule. But what we have inside here is not just my variable, it's my variable plus 1. And if I had any more complicated thing under the square root, I would need to do the same sort of thing that we're going to do here. And the big idea is to sub for the inside. Substitute for the inner function. So here my inner function is x plus 1. So I'm going to make the substitution u equals x plus 1. there are several catches to trying to do a substitution in an integral. The biggest sort of catch is, what do we do with the dx? I know that x plus 1 is just going to become u, so the integrand, the piece inside here, is just going to become the square root of u, and that looks good. That looks more like this. But I need to also change this dx to something in terms of the new variable. The way you do that is by calculating the differential, du. The way you calculate a differential is by differentiating this and then multiplying by dx. So du is 1 dx, because the derivative of x plus 1 is 1 plus 0. And I'll make another note here. If u is equal to, we call it g of x, then du is g primed of x times dx. So how do you get the differential du? You just differentiate this thing and then slap on a dx, right? So the derivative of g is g primed, and then you slap on a dx. You can think of it like du dx equals g primed. That's the normal Leibniz notation that you saw in Calc 1, and you just multiply both sides by dx. Mathematicians don't like that because you're not supposed to be able to multiply by dx, but it works. It works fine. So when I make this substitution in that integral, what we're going to get is the integral of the square root of x plus 1 dx. That's why you always need to write your differentials, because we need to replace them, is equal to the integral of the square root, well, x plus 1, that's just u. And then over here, du is equal to 1 times dx. This means dx is equal to du. So all I do here is swap this for whatever I get when I solve this for dx. And you may want to add that to your note here. This would imply that dx is 1 over g primed of x times du. And in general, that's what you do. You have to go back and solve your differential for dx and then plug it in. The big idea is that you should not have a dx here anymore. You should have a du. And you may have some other shit floating around. You have to get rid of all the x stuff. So if, when you do this, you still have some x stuff floating around in here, you'll have to find some way to either make it go away or rewrite it in terms of the new variable u. Now in this example, we don't have any other x stuff floating around. I've just got an integral. I've got a pure function of u, no x's, just u's, and I've got the differential du, because du and dx are the same here. That means I can proceed the same way we did above. This is going to be 2/3 u to the 3/2 plus c by the prior work. The only difference is the variable here is u, right? You look back at that first example, we integrated the square root of x, and we got 2/3 x to the 3/2 plus c. Here I'm integrating the square root of u, so I'm going to get 2/3 u to the 3/2 plus c. And then finally, because it's an indefinite integral, no bounds, I'm not going to plug in some numbers or anything like that. I just have to go back and replace my substitution with what it was. I wanted to know, what's the integral of the square root of x plus 1? Well, that answer has to be a function of x. So this is 2/3 quantity x plus 1 to the 3/2 plus c. I'm just plugging in. Just going back and plugging in what we had for you. We only do this step on indefinite integrals. With a definite integral, we change the bounds and then plug those new bounds into this function. I'll show you what that looks like in just a second. First, are there any questions on what we've done here? Okay then. I will generally preface examples with this e.g. It's Latin for exemplus grati, or many examples exist. Next example. I want to evaluate the indefinite integral of 2x times the square root of x squared plus 1. And that same big idea is going to save the day. I want to substitute for the inner function. It's this square root that's giving me a hard time here. If not for the square root, I would distribute the 2 and split it up as a polynomial and then integrate each of those pieces using the power rule. But the square root means this is not a polynomial, can't be rewritten as a polynomial. And again, I'm going to remind you, personal pet peeve of mine, the square root of x squared plus 1 is super duper not equal to x plus 1. This shit never works. Don't even try it. I know it's tempting. I know it's tempting, but it's just not true. Plug in some numbers, right? Plug in 2 for x, or plug in 1 for x. Then here you get the square root of 2. Here you get 2 itself, right? 2 is not equal to the square root of 2. So we can't do that. But we can lean on that same big idea, sub for the inner function. Really, u-sub is the backwards chain rule. It's literally that. If you want to prove the u-sub formula, which is in your textbook, and I'll show you, the way you do it is by differentiating on both sides and then referring to the chain rule. So just like in the chain rule, you think of the inner function as its own thing, and then you multiply by the derivative of the inner function. Well, here, I'm thinking of this as the inner function, and conveniently, we have the derivative of the inner function there. That's going to be really helpful in our substitution, because when I let u be x squared plus 1, this time du is not equal to dx. This time, when I calculate the differential du, what do I get? Who can help me with this?
2x dx.
Very good, 2x dx. It's the derivative of this thing, which is 2x, and then we multiply by dx. Now, when I do these, you're going to see me put these little substitutions in a box. I would say that's good notation, and I recommend you do the same, because it's not a part of the main workflow, which is going to be over here. It's kind of off to the side, and you want to make sure your reader, in this case me, knows what you're doing. So kind of putting your little substitution in a box off to the side, good move. Don't have to do it, but I suggest it. All right. If I want to plug this in, let's just see what happens. I'm going to do one thing at a time. So I'm going to leave that 2x. The square root of x squared plus 1 becomes the square root of u, because u is x squared plus 1. And dx, I'm just going to leave as dx for now. This thing on its own has no meaning, because it has a mixture of variables. It has u's and x's. It's got a dx here. That's not okay. You cannot integrate at this step. So in order to proceed, we need to get everything in terms of the new variable. And I mean everything. There can't be a single x left in this expression before we do the integration. And here the new variable is u. So how do I do that? How do I get rid of this 2x and get rid of this dx? Well, there's a couple ways to think about it. I'm going to show you the way I like most. But first, I'm going to show you the way that most students I've seen do it. you come back over here and you solve this for dx, right? So if I want to solve du equals 2x dx for dx, I get dx equals 1 over 2x du. And then you plug that in. So here you'll have integral 2x square root of u times 1 over 2x du. And miracle of miracles, the 2x's cancel, because everything here is being multiplied. So you get just integral square root of u du. And we've seen this integral thrice now today. You know that this is 2/3 u to the 3/2 plus c. And then finally, you plug back in for your substitution. So that's now 2/3 x squared plus 1 to the 3/2 plus c. All right. Now the alternate approach and the way I prefer to think of this is to take this guy and rewrite it as integral square root u times 2x dx. And now look at this. 2x dx, that's du. You know that 2x dx is du. So you can just rewrite this as integral square root u du. There's no like mixing variables or canceling. I like this because it avoids this step. It avoids this step where you mix the variables, which is an ugly thing, right? You can get into a lot of trouble here by like accidentally trying to pop an x out of the integral or shit like that, which never ever works. Right away, you can say, okay, here's my differential. Here's this piece is going to be square root of u, this piece is going to be du, and then again, the same result from the power rule. And then you plug back in. All right. So kind of recognizing your differential in the integrand is a big skill. It's a good skill to have. You can say, okay, which piece am I substituting for? Which piece am I going to use with my differential? And when we talk about integrals of trig functions, this way is going to be by far the nice way to think about it. But as you get used to this, especially kind of fresh coming out of Calc 1, I know that most people come back here, solve for dx, and then plug in and try to cancel. That's okay too. Just make sure that you remember the little blue note here. You can't do any integration at all with a mix of variables. You have to get every single piece in terms of just the new variable. Once you're there, you can proceed with all the rules you remember from Calc 1. All right, any questions on these? Okay. How am I doing on time? 10:39. I have you guys for like 5 more minutes, right? So let me show you one example with a definite integral. There are some things with definite integrals that I'm very, very picky about, and I'm going to require you to be very, very picky about. Again, this is a little substitution problem. I'd like to integrate from 0 to pi over 4 the function sine of 2x dx. So here we're going to be using an antiderivative we haven't talked about yet. I can say off to the side that we know indefinite integral of sine x dx, who integrates to, or who differentiates to sine.
Is it negative cosine?
Very good, because the derivative of cosine is negative sine. So negative sine would be sine. So yeah, this is negative cos x plus c. But I don't know what to do with the 2x, at least not right away. But following the thing that we said earlier, sub for the inside function, right? Substitute for the inner function. So we sub the inner function. Which here means making the substitution u equals 2x. And my differential, du, I find that by taking the derivative of 2x. The derivative of 2x is just 2. So that's 2 dx. I'm going to open my little box here, but I'm not going to close it because I'm going to put something else in this little box. And I usually put a little dotted line over here. You got to change your bounds. So when x is equal to 0, what is u? And when x is equal to pi over 4, what is u? How do you find this? Well, you plug the old bounds in here. This is the equation that tells you how u, the new variable, is related to x, the old variable. So when x is equal to 0, u is equal to 2 times 0, which is still 0. Just plugging in here. And when x is equal to pi over 4, u is equal to 2 times pi over 4, which is pi over 2. So the integral we're doing here is a definite integral. It has bounds, which means the answer is a number, not some function plus c, just a number. When you do your substitution, in order for the new integral to be equal to that old integral, that new integral also has to be a definite integral, right? If you write equals and then you write some indefinite integral where you've done this substitution without doing this shit, you've told a lie. It's not okay. When you do a substitution in a definite integral, anytime, any substitution in a definite integral, you must change the bounds. So when x is equal to 0, u is also equal to 0. When x is equal to pi over 4, u is equal to pi over 2. That means my new integral is going to run from 0 to pi over 2. New integral, new variable, new bounds. Because what we're doing is called a coordinate change. We're moving from working from the xy axis to working in the uy axis. And the u axis is not the same as the x-axis. I'll show you some pictures to try and convince you. Everything else goes the same. So sine of 2x, what's that? Oh, that's the sine of u. Dx, what's that? Well, dx is 1/2 du. I'll do it this way. So I get the sine of u times dx. Dx is 1/2 du. And since that 1/2 really is just a constant, it can come out of the integral. If it were not a constant, if it had any x's in it or any variables in it, could not come out. But 1/2 is a constant. So this becomes 1/2 integral 0 to pi over 2 sine of u du. And now I can lean on this fact over here. I know that an antiderivative for the sine of u du, right? When I do this integral du, I get negative cosine. It's a definite integral, so I'm not going to write a plus c. Instead, we have to evaluate between bounds. And the 1/2 is going to come along for the ride. So this is going to be 1/2. I like to put my stuff in brackets. Antiderivative for sine u is negative cos u. And then there's two notations for this. You can either use a bracket like I'm doing on the right, or you can put just a vertical bar here and a 0 to pi over 2 like that. Either one you like, doesn't matter. The evaluation brackets are linear functions of the inside, so this negative can actually come out. So I write negative 1/2 and then cos u evaluated from 0 to pi over 2. And then you plug in the upper thing and subtract what you get when you plug in the lower thing. So this is negative 1/2 times the cosine of pi over 2 minus the cosine of 0. Alrighty, and then we're almost done. That negative 1/2 still coming along for the ride. What is the cosine of pi over 2?
Zero.
Yeah, got to know that unit circle. So cosine of pi over 2 is 0. So I have 0 minus, what is the cosine of 0?
1.
1. Very good. Okay, so I have negative 1/2 times 0 minus 1. That's negative 1/2 times negative 1 is positive 1/2. All right, I said it. I'm going to write it down. You must change bounds. When substituting in any definite integral. And on a test, I will take points off if you do not. I know there are other ways to arrive at the correct answer, but for very serious and meaningful reasons, those ways are wrong. And the very last thing I'm going to do here is point you to a resource to convince you that what I'm saying is true there. Before I do that, any questions about this? When we talk about improper integrals and things like that, this procedure will be very important. So I want you to get in the habit now. Okay, let me try to convince you that substitution in definite integrals absolutely requires changing bounds. I've actually referred to this so often that it's here in the modules under review materials. So if you come to your modules page, go to the very bottom of review material, you'll see why we always change bounds when solving indefinite integrals. There's a really nice page on this. And they're looking at, kind of a basic problem here, and we'll look at problems like this in the future. But here's what I want you to think about. Oh my God, this dog. Maxie. Come on. No, it's not loading. So come back over to the dot cam. Imagine I want to integrate the red function from 0 to 1/2. That's this area here, under the red function from 0 to 1/2. When I make that substitution, it becomes the blue function. Or if I substitute in the blue, it becomes the red. In order to get the same area, we would have to integrate the blue function from 1 to 1.5. You see, this region is identical to this region in its shape and its size, but you have to change your variables. You have to change your bounds of integration. To get the integral of the blue from 1 to 1.5, you'd integrate the red from 0 to 0.5. You can just see that this region has the same shape and size as this region. So you're really changing coordinates. When you make a substitution, you're changing the horizontal axis of your graph. And sometimes a really simple substitution like u equals x minus 1 just shift things left or right. The thing that scales the x-axis into the u-axis, like stretches it or compresses it, that's the differential term, the dx. So if you're wondering why it's so important to change bounds in a substitution, or you're wondering what does the dx really do in your substitution, I really encourage you to check this out. This last link in the review material module, it'll help you understand that. And it's a really nice explanation. All righty, that's all I have for you guys today. Be on the lookout for your first homework assignment. It will be up a little later today and will be due at the start of class next Monday. Is there anything you guys would like to ask before we wrap up? All righty, then I'm going to go ahead and end this one, and I'll see you guys on Wednesday. Take care.
Have a good one, Professor.
Pleasure.
You too.